Hi statistics student, this video is for chapter 3.3 and 3.4 part 1. We'll look at particularly events that happen in a sequence. So instead of 3132, we are only looking at selecting one subject, so it's all related to sampling. We are looking at sampling multiple subjects, so this is multiple events, but we are not looking at events with different category, but with different steps. And so it involves sampling. So we will look at there's two different types of sampling. One is sampling with replacement, and the other is sampling without replacement. And usually when we do a statistics, we usually sample without replacement, because without replacement means you keep your sample after you pick one, and your selected one will not be in the pool for the future selection, and all your selected subjects are unique. This is the default assumption for sampling, because say for example you want to do a survey, you don't want to interview the same person twice, right? There's no use to do that. So or when you want to measure something from your subjects, the subjects are selected, so they're all unique, they're all different. So sampling without replacement is like kind of the default, unless they say sampling with replacement, which is putting it back so that you can select it again and again. So select subjects are put back into the population before another subject's sampled. Subject can possibly be selected more than once. Kind of like you have a marble jar, some are red, some are green, and then you pick one, you look at the color, and then you put it back and you pick another one. So these are called with replacement. You replace it before you sample another one. Okay, and the default is without replacement, unless they say so. So say for example they say you do 2 times, or you select 3 people. That means 3 different people. Okay. So let's look at it in general as something called compound event. But this compound event is not an event that has multiple categories, but multiple steps or trials. So one procedures that include multiple trials, like sampling. When events involve multiple steps, they are called compound events, and the compound events are also called A and B. So it's really confusing. In the last 3.1 and 3.2, we talk about A and B being one cell in a contingency table that has 2 categories, but the same description is for an event that has multiple steps. But we can almost look at it as A and then B, but not A and B, where A, B are outcome of one step with 2 categories. These are both are labeled as A and B, but they are the way to find the probability is different. Okay, so to find A and B where they are in multiple steps, we use multiplication rule. So probability of A and B is when A occurs in the first trial and B occurs in another trial. Kind of like you toss 2 coins, you toss it once, and then you toss it again, right? So you have head or tail, or head or tails. So it is the second time, so it is 2 steps. Okay, it is not just one coin and look at the coin, does it has head or tail or any other things, right? So the way to find A and B, that means the first is a head, the second is also a head, is probability of A first times probability of B after A has occurred, because this is the second step. B is the probability of B is always a conditional probability. So probability of A times probability of B given A. So this is by default how you calculate A and B. Again, this and is and then, not the one cell that we talked about. Now to calculate this, we can simplify a little bit, because you can see how it is difficult to do this conditional probability. By default, we assume that B would depend on how A has happened. So this is the default formula for probability of A and B, because we assume that the second event affect the first event affect how B happened. But we can have an event called independent event. Now this is different from what we have been talking about independent, where two categorical variables are independent. That is some other things. In statistics, these terms, independent, show up so many times. So in sampling or in an event where we have multiple steps, independent means one step does not affect the other. You can think of it as almost like the two categorical variable. The choice of one variable does not affect the other one, and the way we check it was probability of A and B equal to probability of A times probability of B. It's the same formula. So if they are independent, you can actually just use multiplication to find A and B. So in general, if we are doing multiple steps, so like you're tossing the coin 5 times, then you can do probably of the first is ahead, the second is ahead, the third is ahead. Keep on multiplying. So not just 2, but keep on. It can go on forever. So a good example would be a fair coin being tossed, and we know that they are independent, right? The first time you toss a coin, and coin toss by itself are independent. How do I know? Because when you toss the second time, it really doesn't matter what you have tossed on the first time. The second time's outcome are independent of the first. So we can use the independent multiplication rule, which just keep on multiplying. So let's find, So why they are independent is really because of the nature of coin toss. It's not because of, you do something. You don't have to do any checking. So the first 3 tosses ahead would be, the first is ahead, so it's probability of ahead, times probability if the second is ahead, which is still a half, times the third one is also ahead, right? So the first is ahead is 1/2, the second is ahead is 1/2, the third is ahead is 1/2, so it's equal to 1/8. The probability of the first 4 tosses ahead, so you can keep on multiplying. The first is ahead, the second is ahead, the third is ahead, the fourth is also ahead. So 1/16. If you want to, you can write it in decimal. But now this is a little harder. At least one head in 4 tosses. At least one head. So that means out of the 4 tosses, maybe the first is ahead or all of them are ahead, but I want at least one. So we would use the complement nature of at least one. The idea would be at least one means in all the outcome, one of them has to be ahead. But that would be complement of all the heads or tails. All of them are tails. The rest will be some kind of heads in the result, right? So because they are complement of each other, so let's say all tail, 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 tail. The other would be have heads and some tail, and some head, and some tail, and some head. So all of them have at least one, right? So if you write the outcome, so in the sample space, this is the sample space, you would have these. This is the only one that are all tail. All the others are just some head. You can have all head also, right? But I really don't know how many there are on the others. For every single one of them, I have to do 1/2, 1/2. So it is a lot of work to do these. So this is at least one. And it is you have to write all of the different combination. So the easiest way is to just have 1 subtract this, which is 1, right? So it would be 1 minus 1/2. All of them are tails is tail. All tails, tails. So it would be 15 out of 16 because you basically 1 minus 1/16. So the idea will be at least one something is equal to 1 of probability of all of the other. The complement. Okay, so the second example would be group of 300 students, no, adults, 300 adults, 200, this is no, that's no. 272 are right-handed. And then you pick 3 adults. You can see that we don't pick 1. If you pick 1, then the probability of having a right-handed adult will be 272 over 300, but I pick 3. And I want to find that all 3 are right-handed and also all 3 are left-handed. Okay. So when they say pick 3, I think they means If they don't say anything, that means without replace. Oh, I think did they say that it is without replacement or with replace? Oh, they say with replacement. So every time you have 300 to choose from, and 272 are right-handed. So the first is right-handed is the one is right-handed is 272 over 300 is 0.907. One right-handed would be the rest of the left-handed are right-handed, right? So assume the other one does not count, so it's 28 over 300. So it's 0.093. And so 3 right-handed means probability of right, and then right, and then right, right? So, and because of with replacement is always independent. Because once you put it back, you still have 300 to choose from. So we would just do, just like when we do coin toss, it's just 272 over 300 times 272 over 300 times 272 over 300, because the second time you do, you still have 300 to choose from. So we would use exponent to do 272 over 300 exponent 3, 1745. All three of them are right-handed is this. What about all three are left-handed? So you would say probability of left and left and left. So you're just multiplying again, right? And because it's with replacement, it is independent. So you just keep on multiplying them. So that would be 28 over 300 cube. So now do not use this rounded number to do cube. Use the fraction to do cube. So you get that number. So it's very low chance of all three are left-handed. It's very rare to have, that. So like in a room of 300 people, maybe you do not need to put like that many. You would not be able to, say you select 3 people, the 3 people are all left-handed is very low. What about at least one right-handed? So we talked about this before. At least one right-handed is 1 minus probability of all left-handed. So it is, what is all left-handed? All 3 of them is 0.0008. So it's really easy, 0.9992. So all left-handed, if you don't, this is the complement. So these two are complements, so you can do 1 minus. Okay. So we'll talk about another features called when you have sampling. So we can you can summarize that when you do sampling with replacement, you can always use the independent formula. But when you do without replacement, you have to do dependence. So it's harder to do because you have to do conditional. So we're going to talk about how we can change sampling with replacement, change without replacement, change, and still use dependent. We're going to talk about how to do that in the next video.